Okay, so the problem we're investigating, and guys, obviously you can just copy that problem down. Okay, I don't get marks for the problem, and copy it straight from there. Hey, we're looking at what kind of motion is experienced by a cart going down an incline. Probably a pretty simple question to answer. Okay. Now, in this lab, just so we can go through the design here, guys, so if you listen carefully, you'll probably get most of the variables here. Okay, we're going to set up the ramps, okay, one trial. That's all we need, okay. We are going to allow enough time for the cart to go down the ramp, okay. Whatever that amount of time is, that's what we're going to allow it to have. We are going to measure its position and its velocity as it goes down the ramp. Both of those should change in response to how long it has to go. For your controlled variables, I'm going to leave those to you, okay? But it should be pretty easy to pick three, right? Some that are conditional, okay? That is things that are staying the same within the room or within the experimental apparatus that we're using that could affect the acceleration of the object, okay? Which of course we want to have stay the same, okay? We don't want the acceleration to change. We want there to be an acceleration, but we don't want it to change, okay? As well as maybe something procedural that you do to set up the apparatus or something along those lines that, okay, is going to be controlled. Okay, remember that you need three controlled variables, each one explained on its own. Okay, don't just say, I'm keeping all of these the same or they'll affect the experiment. No, each one gets its own explanation. Okay, I'm controlling this because it would affect the experiment in this way, and okay, this is how it's being controlled. Do that for each controlled variable. Okay. And obviously you have to explain the manipulated and the responding as well. Here's how the manipulated is being manipulated and why. Here's how the responding variables, plural, in this one, okay, are responding and why.
We're just doing it once, or?
Just doing it once. Yeah. Okay, so the data collection for this lab should go like that, right? I mean, we're running the cart down the ramp one time, and if it looks good, then that's it, we're done. We're putting the equipment away, and we're getting right into building the graph, doing the analysis, all of that kind of stuff. All right, so this, like I say, you should be able to get a lot of this lab report done in class today and not have too much homework for it. All right, talking about the hypothesis, sorry. The if part of our hypothesis, okay, should talk about what acceleration is. So if acceleration is basically just a definition, okay, of acceleration for the if part. If acceleration is this. Okay, and part just describes the experiment, okay, and a cart is allowed to accelerate down a ramp with its position and time recorded. That's what we're doing. So for the then part, okay, I'm going to want you to tell me how you'll know acceleration is occurring and how you would calculate it. So my suggestion here would be you're going to have a position versus time graph and a velocity versus time graph. Maybe talk about what the shape of those would look like for an accelerating object. Okay, because the shape of your graphs can tell you if the object is accelerating. Okay, if you put in there a prediction of what the graphs will look like, and then tell me how you could calculate it using specifically your velocity versus time graph, since we talked about that yesterday, okay? How you would calculate the acceleration. That would be a good then part, okay? What will your graphs look like for an accelerating object? How will you calculate it from the velocity time graph? So like I said, procedure is simple. Take a track, build a ramp. The ramp does not need to be very steep. Okay, to give you an idea here, okay, I used 3 of these red textbooks. Okay, that would have made it, what, 12, 15 centimeters tall. Okay, something like that. Okay, it doesn't need to be, don't put it up on the chair of a desk. Okay, it'll go down so fast that you won't get any data. And those things record 20 times per second. Okay, we'd like to get a few data points, and a graph about this tall, or sorry, a ramp about this tall works best. Okay, also please build your ramp on the floor. Okay, I don't want anything off the desk and crashing into the floor. That will provide an interesting graph, but that's not what we're looking for. Okay? Questions? All right, let's get the data collected, and then we'll talk about what we're going to do with it. Okay? All right. If you don't have anything to build the ramp with, okay, let me know. But a couple of binders or whatever you have in your backpack will probably work. Okay? But if you need something, I can provide a few books. I'll put a few on this desk here. All right? Okay. Let's get to it. Just going to walk through what you need to do with your data here. Okay, as I said, the carts record everything. It would be really nice if we could just tell them to record one thing, but we can't. They just record everything. So what we want to have here are 2 sheets. Okay, one sheet that just has the time and the position on it, and one sheet that just has the time and the velocity on it. So we can build 2 separate graphs. Okay, so what I would do is copy column B. Okay, and then make a new sheet down here. Just hit the plus button. Okay, and then just paste the time in there. And then bring the velocity, or bring the position over. Okay, and then on the other one you can just leave, you can delete everything else and just leave the velocity in there. Okay, or whichever way you want to do it. So go back to my original page here. Okay, and find my velocity. It's right here. It's column I. All right, so I'm just going to copy that and bring it over to that second sheet. Okay, and then I'm going to go back to my first sheet and get rid of all the stuff I don't need. Okay, so I'm going to get rid of that one. Okay, so I get to this point, now I have 2 sheets. I've got one with time and one with velocity. Here's the thing that's super important. We want these 2 graphs to show exactly the same points. We're going to have to edit this, right? We have to take some points off. We know that there are some points where the cart wasn't moving yet, or after we stopped it at the bottom. We need to make sure that both graphs show exactly the same points so that when we calculate the displacement, it matches up. Right? If I use a position versus time graph to calculate the displacement of the cart as it goes down the ramp, I should get the same number as when I use the velocity versus time graph to do that, because it's the same cart, it's the same run. But if I don't have the same points, I won't get the same number. All right, so what I want to do here is obviously first build the graph, okay, for the position versus time, and that's how I'll know what points I need to keep. Holy smoke, why do I have so much data here? Okay, that's so weird. All right, so insert your chart. Okay, it made a line chart. I don't want that. I want a scatter plot, so how to do that. Okay, so obviously the part of this graph that I want to keep is probably between here and here. Right? The rest of it is kind of unimportant. So looks to me like, you know, about 2.5 seconds or so. After that, for me, I want to get rid of. You got to find whatever that time is for you. But here's the thing. Whatever points you delete from this graph, you have to right away go over to the other sheet and delete the same ones. Okay? So if I decide I'm going to delete everything after, so I'm just going to scroll up here. And I can see it's like the same number here. All right, here we go. Yeah, so right here at about 2.75 seconds or so is where it looks like, oh no, it's still accelerating a little bit here. Well, I'm going to stop. I'm going to start right here. I'm going to delete everything after 3.15 seconds. Okay, I still need to do a little adjusting, would you agree? Right? I don't want to have this part, I just want this upward curve. So probably got to go back to 2.2 seconds, probably, something like that. Okay, so I'm just going to go back to my data here. All right, so 2.2 I think is where I said. 2.3 still looks good. I'm going to stop at 2.35 seconds. I'm going to delete everything after 2.35. Again, you have to decide on how this looks for you. Okay, those are the ones I'm selecting for my data. Okay, now I look at my graph. Okay, yeah, I did a good job. I picked the right ones. So I deleted everything from 2.35 seconds on for my position data. Now I go delete exactly the same points off of my velocity versus time data. So I go to my second sheet. Okay, I scroll till I get to 2.35 seconds. Okay, and then I'm going to build a graph on there as well. Okay, so the key thing here, guys, is I need to delete the same points. Looks like I've got to delete 2 more still. Okay, now that I've got my other graph built, still got 2 more points I've got to delete on this graph. And you'll see that sometimes. You'll see it more evidently on the velocity time graph than you will on the position versus time graph. Okay, so I've got that. So I want to delete my last 2 points on there. So I'm going to get rid of those as well. And then I'm going to go back to my position time data and delete those as well. Okay, so 2.25 is as far as I want to keep. Okay. Looks pretty good. What else do I have to do here?
Trim everything below 1 second.
Yeah, exactly. I'll probably keep everything from maybe 0.95 seconds and delete everything before 0.95 seconds and then shift up. Okay, so in case you've forgotten how that looks, okay, 0.95 seconds. Okay, so I'm going to do this, go to 0.9, and actually I'm going to go to 0.85. I like just the way that looks. And I'm going to highlight just the position data, edit, delete, shift up. Okay, so now, down to my graph again. This is way down here. Oh yeah. Okay, that's exactly how I want that to look. All right, so I'm going to go to my other graph and delete the same points. Okay, I went to 0.85 seconds. I deleted everything before that. Okay. Yeah, that looks pretty good. I think I'll keep that one. Okay, now I've got exactly the same amount of time on both. Okay, I do have to delete some time numbers here because for whatever reason they're still there. I don't need them. Okay, delete those, and I'll do the same thing over here to clean up my graph a bit. Okay, once you've got those graphs built, the only other thing you need to do is put a line of best fit on the velocity versus time graph. Obviously, you don't need a linear line on an exponential graph. Okay, so don't put a best fit line on the position versus time, but do put one on the velocity time and get the equation for the line. Okay, and then copy the graphs, and the graphs only, into your lab report. Okay, if you open up the Google Doc for that, there's a spot where it says insert charts and graphs here. Okay, just put your graphs in. I don't need the data chart, just the graphs. Okay, so I want to see a position versus time and a velocity versus time graph in there. Okay, and then you've got your analysis there. Using your graphs, identify the type of motion that occurred in this lab and show calculations to prove and explain your reasoning. So I'm looking for two things in that answer. Okay, if you're playing with your graph right now, you should stop and pay attention here. Okay, I'm looking for two things in question number one. The first thing is talk about how the shape of both graphs indicates acceleration is occurring. Okay, and not just as simple as it has this shape, this means acceleration. Explain. Why does that shape mean acceleration? And then I want a calculation from the velocity versus time graph. Maybe you don't really need to actually calculate anything, okay? But show me how you would mathematically get your acceleration from the velocity time graph and explain. That's question number one. Two things in question number one. Okay, and then in question number two, okay, there are two ways to find the displacement of the object. I want you to find the displacement from the position time graph and the displacement from the velocity versus time graph. Spoiler alert, those should be really dang close to the same number. Okay, if you are out by more than 10 centimeters, you probably did something wrong. Okay, most of the time when people do this, they're within a couple of centimeters, okay, for the numbers they get from each graph. Okay, so show me those calculations. Okay, then same as always, conclusion, sources of error. You have the rest of class to work on that. If you've got questions, pop up and see me, okay?